All right. For those of you who are returning students into this class, we've already had you recall we've already commenced this class some a week or so ago, and today is a continuation. My intention is to finish up this course in about 3 or 4 classes. So tell your friends, tell your classmates that it will do them well to attend this class. Automatically, attendance is taken and it's recorded. Chidebere Martins Chikezie, you are here. Justina Yakubu, you are here. And before the end of the class, I will take again. We've already introduced this class initially, Thermodynamics 2. You had taken Thermodynamics 1 sometime in your year 1. So the 200 levels is a continuation. This is MCH 205. My name is Engineer Osita Arukwe. I'm your lecturer for today. Wherever you are joining in from the world, in this online class, live online class, you're welcome. If you happen to be watching it, if you happen to be watching it later, you're also welcome. We have gone a bit further. We've gone a bit far in this lecture because we have introduced what thermodynamics 2 was all about. We have talked about um, the systems, talked about chemical reactions, separated it from separated it from mixtures. In mixtures, we talked about heterogeneous mixtures and homogeneous mixture. We compared it with chemical reactions, and it was clear to us that mixtures were physical. Okay, sorry about that. We had okay, can you hear me now? Can you hear me now? If you can hear me and see my screen, type 22. If you can hear me and see my screen, type 22. If you can hear me and see my screen, type 22. All right. So we talked about chemical reactions. We went further to stipulate what we observe in chemical reactions. We saw some chemical reactions like synthesis reactions, decomposition reactions, and we defined what they were. We also looked at single replacement reaction, double replacement reaction, and slided into stoichiometric chemical reaction, where we understood that stoichiometry was all about the quantities of reactants and products that are involved in a chemical reaction. We started rounding up that particular lecture by talking about enthalpy, where I gave some research work for you to do, and entropy. We looked at the enthalpy of formation, where we gave some standard factors or conditions for enthalpy of formation. Today, I guess we are all seeing my screen now, so that has gone, that is mute. Today, we are going to be looking at compressors and the classifications of compressors. What is a compressor? A compressor is a device that increases the pressure of a substance, usually a gas, by reducing the volume of that substance. And if you look on the right side of my slide, you will see a pictorial on a compressor, a pictorial of a compressor. And so compressors are used in many applications in engineering and in real life. What it simply does is that it involves increasing the pressure inside a gas storage container, such as compression of gases in petroleum refineries and chemical plants. Air compressors, because most compressors are air compressors, they work by forcing air into a container and pressurizing it. That is, constricting it in such a way that it builds up pressure. Then the air is forced, intentionally forced through an opening in the tank where pressure builds up. Think of it like an open balloon. You remember what we used to do? What Those of us who did that, what we used to do when we were very, very young, you will blow up a balloon, then hold the mouth, constrict the mouth such that you open it bit by bit. You understand that there's a sound it makes when the air is forced out. So that is what a compressor basically does. So if you look at um, the diagram, the pictorial by the right, you would see it starting from one. Spinning rotor is off center. Number two, arms with self-adjusting lead creating cavity of varying sizes. This cavity of varying sizes sucks in air. Air fills the cavity and around it. As the cavity gets smaller, air pressure goes up. So the cavity becomes smaller and smaller. So it builds up pressure. Then it is forced out through another output. That's what happens. What are the types of compressors that we have? We have the positive displacement compressor. On the left there, the ones on the yellow side, the positive displacement compressor that is divided into reciprocating and rotary compressors. The reciprocating is divided into single acting, double acting, and diaphragm compressors, while the rotary compressor is divided into lobe, screw, and vane compressor. Also, the liquid ring and scroll compressor. While the dynamic compressor is divided into centrifugal and axial compressor. All right, air compressors are categorized as either positive displacements or dynamic displacement based on their internal mechanism. So your first research work, I want you to go read up and understand more about positive displacement and dynamic displacement. Understand the different type of compressor that positive displacement does and dynamic displacement. Those of you who are in the class, I hope you have gotten that. The advantage of being in class when a lecture is going on is that you get to hear some things that will be very beneficial to you that may not be in your handouts or your materials. So those of you who are here, take this as one of your advantage. Go and read on go and read more on displacement, positive displacement compressors versus dynamic displacement compressors. If you got that, can I see you type 2-2? If you got that research work, can I see you type 2-2? All right, while that is going on, there are basically four most common types of air compressors. There is a rotary screw compressor, there is a reciprocating air compressor, there is the axial compressor, and the centrifugal compressor. These are the main ones we are going to be looking at. Let us look at some of the definitions of these compressors that I have mentioned. A positive displacement compressor, which is one of the main type of compressor. Remember, we have the positive displacement and the dynamic displacement. These are the two main, and they are subdivided into bits and pieces of other ones. Okay, so the positive displacement compressors encompass a variety of different air compressors. So positive displacement compressors is made up of so many types of compressors. But generally what they do is that they generate power via air displacement. Air compressors in this category work with different internal mechanisms, but the principle of each is the same. A cavity inside the machine stores the air brought from outside and then slowly compresses the cavity to increase the air pressure and potential energy. This is basically the most popular type of air compressor, the positive displacement. There's a displacement of air and it creates pressure and is now pumped out through another orifice. So this is basically how most compressors work. Let us look at rotary screw compressors. Now, these are basically equipped with an internal cooling system and they don't require much maintenance. They are typically large industrial sized machines that can be either lubricated with oil or they can run oil free. All right. Now, rotary screw compressors generate energy via two internal rotors that turn in opposite directions. the air now does what? The air now gets trapped between the two opposing rotors and builds up pressure within the housing. I'm sure as I'm explaining this, your mind is running free. You are interchanging what you are reading and what I'm saying with your mind. You are imagining this happening. Two rotors are enclosed in a housing and they are running or rotating in the opposite direction. When air is sucked in, the air is trapped in that housing in between the opposing rotators. Now, this builds up pressure, obviously, within the housing. Now, because of the internal cooling system, the air compressor are designed for continuous use and range in power from 5 horsepower up to 350 horsepower. There's an internal cooling system. Now, if that internal cooling system is not there, of course, the pressure will build in such a way that it can burst. So there's an internal cooling system that cools the pressure that builds up because of the air that is trapped and the rotors that are in opposite direction. Now, there's what is called the reciprocating compressors. These work via a piston inside a cylinder designed for smaller sites and non-continuous use. Reciprocating compressors are not usually used continuously, unlike the one in the previous one, the rotary screw compressor that we saw in this slide. Now here, it's also a displacement compressor, the reciprocating compressor, and they're usually used for small sites. This type of air compressor works via a piston that is inside a cylinder, which compresses and displaces the air to build pressure. So when it slides up, it sucks in air, and when it pushes down, it pressurizes the air and it comes out in the other orifice. So reciprocating compressors can come in single variation or multi variation. That means you might have a compressor that has only one piston, or you might have a compressor that has more than one piston working together. When you need more power, then you will now have a reciprocating compressor that has more than one piston, which is now a multiple stage compressor. We have the dynamic compressor, which is the second major type of compressor that we have. And what's a dynamic compressor? It is used rapidly. It is used rapidly rotating blades. It is made up of rapidly moving rotating blades that draw in air, and you will see this in very big industries, industrial layouts and so on, that sucks in a lot of air. The rotors suck in a lot of air because the blades are huge. And these dynamic air compressors generate horsepower by bringing in air with rapidly rotating blades and then restricting the air to create pressure. The kinetic energy is then stored as static within the compressor. Of course, like in what we do here, you are expected to do research work, understand some of these, get the basics of some of these terms and concepts, then do your research work to broaden your knowledge. In axial compressors, these are highly efficient but very expensive. They are used in ships, airplanes, jets, supersonic jets, and so on and so forth. All right. Sorry about the network. I understand the network is a bit bad, but it's still appreciable. The axial air compressors are not typically used in construction projects. Yes, but are found in high-speed engines of ships and planes. The centrifugal compressors produce a high amount of energy for large-scale manufacturing plants. This type of compressors are slow and cool the incoming air through a diffuser in order to build up potential energy. They require less maintenance than the rotary screw or reciprocating compressor, and sometimes can produce oil-free air. They are usually used for high demanding construction sites. So this is very huge. Centrifugal compressors are very huge. Remember that we talked about single stage and multiple stage compressors when we were talking about the working principle in a reciprocating compressor. The reciprocating compressor. Reciprocating simply means give and take. So the piston gives and takes. It gives, it takes, it goes up and down. So that working principle, like I told us, you can increase the efficiency or you can increase the pressure by creating more than one piston so that you will not have a single stage compressor, you have a multiple stage compressor. So what is a single stage and a multiple stage compressor? The former one, the single stage, involves air being drawn into a cylinder and compressed to a single piston stroke to a pressure of approximately 120 psi. Then it is sent to the storage tank. All rotary compressors are single stage compressors. While multiple stage compressor occurs has the same concept like the single stage, except that the air is not directed excuse me, to the storage tank. The air is sent via an intercooler tube to a smaller high pressure piston and compressed a second time to about a pressure of 175 psi. Then it is sent through the aftercooler to the storage tank. Understand the process here. In a multi-stage compressor, it involves more complex kind of operation. The same thing that happens in a single stage happens in a multi-stage. However, instead of being sent to a storage tank like the single stage, it is sent to is sent via an intercooler where the air is cooled down a bit to another container or another area where there is a high pressure piston working on it that will compress it a second time to about 175 psi. Then it is strength via the aftercooler now to the storage tank. So basically the differences between single stage and multiple stage compressor. In a single stage, only one cylinder is used for the compression, while in the multi-stage, more than one compressor, more than one cylinder is used. In a single stage, compressor used in low pressure ratio application. That means there is a low pressure ratio application in a single stage, but in a multi-stage, there is a very high pressure ratio. Of course, the air taken in and the air taken out in a single stage, the ratio is very low, but in a multi-stage, the ratio is very high because there's a lot of processes that is involved there. The efficiency, volumetric efficiency for a single stage is very low, but for a multi-stage is very high. Now, the temperature of the fluid due to compression is very high. No intercooler while a multi-stage compressor temperature Okay, sorry about that. There was a break in communication. So we were looking at volumetric efficiency. In volumetric efficiency for the single stage, it is low. Is low for the single stage, but for the multi-stage, it is high. So basically, these are all the single stage and multi-stage differences for each of the compressors. If you I believe that some of you or most of you, which is my advice to all of you actually, is to always come with a pen and a paper to the class so you can jot down notes. I believe that you have jotted down some of these differences as the slide has been on for you to have done so. Of course, like I said earlier, and well, I've always reiterated, I will ensure you get these materials, but you will not get it now because I want you to concentrate and not have a spoon feeding mentality. I I do not intend to sell any handouts. Been saying that in my classes. I intend that as my engineering students, you will be not only good in your education in engineering, but good as an engineer practicing in future. So I will support you as much as possible to see that you get as much material that will assist you. I would also, in the course of these classes, point you out to some sites that you can do some research work and get much more knowledge. So my promise to you, I'm not going to sell handouts. So save your money and use it for something better. But I'm going to let you have these materials that I've prepared so that it will help you free of charge, so that it will help you understand better. But you need to pay attention in class, take down notes, do your research work, and do your assignments to be able to understand better. I hope I'm not speaking to myself. If you're hearing me, can you indicate that you're hearing me and you have understood what I said? All right, we'll be looking at intercooling. In intercooling, this is a process. All right, just in case that you are logged out, just re-log in and continue with the lectures. In intercooling is a process of cooling the heated and pressurized intake air after the turbocharger or the supercharger before it enters the combustion rather, the combustion chamber. Remember in the previous class, in the previous slide, we talked about in single stage and multiple stage, and the difference is that the air that is that's been pressurized from the single stage com, pressure is supposed to be sent to the storage tank. Then from there it exits. But in a multi-stage, which involves more than one piston, from one stage, from the first single piston that pressurizes the air, it does not go to the storage tank. Where it goes to is the intercooler. From the intercooler tube, it goes into another smaller high pressure piston. Then from there to the where it is pressurized to about 175 psi before it is sent to the aftercooler before to the storage tank. This is what we said, and that is what we are showing pictorially here as our intercooling in gas turbine. So the intercooling is a process of cooling the heated and pressurized intake air after the turbocharger or supercharger before it enters the combustion chamber. In the stage of the multi-compression in a gas turbine, after the compression of gas in the first compressor, its pressure and temperature are increased. This gas now passes through the intercooler where the temperature decreases. The intercooling process is done by passing an extra amount of water or air. Look at the diagram there. Look at where number one is. Is a low pressure compressor. It goes through number two to an intercooler, It comes into another compressor that is a higher pressure compressor. It goes through the combustion chamber where fuel, water, or air is inputted in it, and it now goes through the turbine that now emits the air at approximately more than 175 psi. All right, let us look at efficiencies of centrifugal compressors and the PV diagrams of them, the pressure volume relationship of the pressure volume relationship that occur in the centrifugal compressors. Now, a centrifugal compressor has efficiency between 70 to 85%, and it depends mainly on mechanical losses and gas friction. within compressor varying with its size. Typically, the isentropic efficiency of a centrifugal compressor is about 80%. Research work for you, research work for all of you here. Go and research about isentropic efficiency, and understand it. It will help you in the exam. Research work. Basically, there are certain factors that affect the efficiencies of compressors. Number one, impure air. Air that contains dirt, dust, and other impurities can cause what is called gunk, which is basically dirt, to accumulate inside an excuse me, inside an air compressor. This builds up wears on parts and reduces internal volume, which can lead to increased costs for repeated air compressor maintenance sessions. All right, then humidity. Water has a high specific heat, which means it requires more energy to change its temperature. Additionally, it collects inside the air compressor as condensation and begins to rust out its parts from the inside. Ensuring that incoming air is as cool and dry as possible is one of the best ways to protect the investment of your compressor and increase its efficiency. So when the air you are using, has a lot of humidity, it can affect your compressor, because the air, when the humidity is high, water content is in the air, and it can result in reduction in efficiency of the compressor. Hot air. Hot air has a lower density than cold air. In turn, cold air is naturally more compressed than hot air, which means it is far more efficient to pump cold air into your air compressor than hot air. Yeah, that is very understandable by itself. Um, you can maximize your air compressor efficiency by um, ensuring that it is cold air you are pumping into the compressor is cold air that is taken in than hot air. That is why, for an example, your car air conditioner, in a hot weather, usually makes your AC, your air conditioner in the car AC, not to work efficiently, and you will not feel chilled air in the car in a hot weather. But in a normal weather, if I will use that word, then you would be getting the effects of your air conditioning system in the car. I want to remind us, if we are logged out, just log in, and we will continue from there. Now, we said we are going to look at PV. We're going to look at PV diagrams. Let me do. Then Emmanuel, it's your mic. It's your mic. Go fix your mic. Every other person is hearing me. Emmanuel Victor, you complained about your mic. You're complaining about not hearing anything. Then it's your mic, because every other person is hearing me. Okay. So if you are logged out, just re-log in and you will join the class. We are in the PV diagrams, the pressure volume diagrams. If you look at this, if you look at my slide, you will see the pressure against volume. A centrifugal compressor imparts kinetic energy into the airstream by increasing the velocity of the air using a rotating element, and then converts this kinetic energy into potential energy in the form of pressure. If you look at that diagram there, you will see how when your pressure is getting higher and higher, when your pressure is getting higher and higher, the volume is also changing.